Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting the definition of differentiation. Before we start our presentation, I would like to introduce our group members. My name is Abdul Wafi bin Omar Jemat, and my group members are Muhammad Alif Alauddin bin Hasran, Muhammad Hazim Akmal bin Abdul Hadi, and lastly is Alif Zamri bin Abdul Razak. What is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. Differentiation is used to determine the maximum and minimum values of particular functions. The rate of change of a function can be defined by dy over dx equals to fx equals to y. To solve differentiation problems, there are various techniques that can be used to solve differentiation problem. In this presentation, we will show you how to solve differentiation problem by derivative of sum and difference, derivative of product functions, which can be called by product rules, and lastly is derivative of a rational function, which is quotient rule.
Hi, my name is Alif, and I'm going to present about the application of differentiation. For this topic, there are 5 subtopics, which is the first one is the related rates, the second one is the analysis of function 1, increase, decrease, and concavity. The third one is the Rolle's theorem and the mean value. The fourth one is the maximum and minimum problem. And the last one is the analysis of function 2, relative extremum, first and the second derivative. So for our presentation, we are going to present about the related rates. So what is the related rates? The related rates are rate of change associated with two or more related quantities that are changing over time. So why we use the related rates? So we use the related rates to compute the rate change of one quantity in terms of rate change of another quantity. So there are 2 steps to use related rates. The first step is find equation that relates the two quantities, and the second step is use chain rule or implicit method to complete the step. I'm going to pass it to my friend.
Hi everyone, so my name is Alif Zamri bin Abdul Razak, and today I am in charge to talk about our problem statement for today. So the problem statement is the radius of a right circular cylinder is increasing at the rate of 4 cm per second, but its total surface area remains constant at 600 cm. At what rate is the height changing when the radius is 10 cm?
Next, I will go to problem solution. The first thing that we'll need to do here is to identify what information that we've been given and what we want to find. From the problem statement, we can define that surface area E is equal to 600 cm. Radius of the cylinder is R is equal to 10 cm. The rate of increased radius dr over dt is equal to 4 cm per second. The rate of change in surface area ds over dt is equal to 0. Did you know why it's 0? The rate of change in surface is equal to 0 because the surface area is constant at 600 cm. For the next step, we have to determine what to find. We have to find the rate of change in height. dh over dt is equal to what when radius is equal to 10 cm. For the next step 3, now that we have identified what we have to be given and what we want to find, we need to relate these two quantities to each other. In this case, we use the formula of cylinder surface area. The surface area formula is A equal to 2 pi rh plus 2 pi r squared. For the step 4, we can find height of the cylinder using the formula by insert the value of radius r in the surface area of cylinder. A is equal to 2 pi r h plus 2 pi r squared. A is equal to 2 pi, insert the value of radius 10 times h plus 2 pi 10 squared. So for the last step is h is equal to 20. After we found the height, we know that surface area is equal to 2 pi rh plus 2 pi r squared. So the next step is we must differentiate the surface area with respect to time. So dA over dt is equal to 2 pi r dh over dt plus 2 pi h dr over dt plus 4 pi r dr over dt. Step 6. Insert the value of radius r and value of the rate of change in radius dr over dt to find dh dt. We know that dA over dt is equal to 0. So I conclude that 0 is equal to 2 pi dh over dt plus 40 pi 4 plus 40 pi 4. 0 is equal to 20 pi dh over dt plus 320 pi. For the last answer is dh over dt is equal to negative 16 centimeter per second. So the conclusion is the height is changing in the rates of negative 16 cm per second.
So unfortunately, we are reaching the end of our presentation for today. So I would like to conclude that identifying the right formula or information and accomplishing first derivative and applying to technique correctly will get the exact answer. So I hope our presentation for today will give some benefit for all of you, and that is all from us. Thank you. Bye.
Bye.